work towards our board examinations, we feel more prepared. We feel more confident. Though 100% confidence never arrives until and unless we write an examination. तब तक हम कभी भी relax नहीं हो सकते. But that's all right. I'm here to help you out with all that stuff. So, that in our series of videos, we have been working towards the ways to ace each section of chemistry by knowing how to give the answers, how to quickly eliminate the other answers, which options to choose from where do we start the papers, and all those tips, right? So you've worked on the MCQ section, which is section A. We have worked on the section B part. We have worked on the case study questions, which is section D. And today, we are going to work on our section C. Now, section C is quite important section because it is containing all those questions which is containing 3 marks for each question, right? Now, it is in this section where we have to write a lot comparatively. Sorry for that. Okay, so basically, we were talking about this section C where we have to write comparatively a lot. For example, there are 5 questions here. Each question contains 3 marks, so it is a 15 mark in total paper. But mostly, this section and the E section takes up the maximum time of yours. Okay, reason, because you have to write. Normally, since it's a 3-marker question, either it involves a lot of numerical questions, okay, where heavy numericals are given to you. आपको solving करना पड़ेगा, either. Or there are multiple subparts, 2 or 3 subparts, where each subpart requires at least 2 to 3 lines. If there are certain examples, you have to give that. If there are certain reactions corresponding to that, you have to write that. So normally, this section takes more time. Okay. And I had a discussion with you that whenever you talk about the internal choices, which we have in a question, try to choose that question, which is first, where you feel more confident. Second, where there are more chances of getting full marks. So that means it is less theoretical question. Okay, because that is the way by which we are going to get +9 marks in our finals. So this is one of the major ways of working towards it. Now, without wasting time, let's get started off by seeing each and every question and working on each of them with all the proper words, highlighting all the important keywords, right? And in this zone, I'm going to give you the way you have to write the answer in the examination. Okay, so let's get started. Out of the 5 questions, this is my 5th question, 26th, where they're asking about the reasons. And please make sure that they are asking for any 3, which means each subpart carries only 1 marks. Technically, 2 lines would be enough to explain each part. 2 lines will do the work. Okay, so 2, maximum 3 if there is a requirement, minimum 1. Okay, but please don't give 1-word answer in these kind of questions. Never do that. Even if there can be 1 word, don't do that. Now there are 4 parts. Let's start with all the 4 subparts. The first part says aniline cannot be prepared by the ammonolysis of chlorobenzene under normal conditions. Okay. Now I hope you all remember that if I talk about the ammonolysis reaction, so ammonolysis reaction is the substitution of halogen with amine group. During an ammonolysis reaction, there is a substitution of halogen with NH2 group. So they want that in chlorobenzene, when ammonia gas is reacted, then it should do the simple substitution like this. So nitrogen should attack here at this carbon and the chlorine should go. It doesn't happen that way. Why? It doesn't happen that way under normal conditions. Reason that this is a nucleophile. It's a nucleophile. Okay. So there are two major reasons for it. The first very reason is that ammonia is a nucleophile and benzene is already electron rich. Therefore, it doesn't support nucleophilic substitution reactions that easily under normal conditions. Right? So there are two major answers for it. The first answer is under normal conditions, nucleophilic substitution reactions are not favorable. Are not favorable on benzene ring. Under normal conditions, nucleophilic substitution reactions are not favorable on benzene ring. That's first. Okay, in this very answer, this is first reason. So when you write this answer, so you will say that the monolysis of chlorobenzene will not take place under normal conditions. This is due to. This is first reason. Second reason is due to resonance, there is partial double bond character. There is partial double bond character between CCl bond, which makes it difficult to break. Which makes it difficult to break. Right? So nucleophilic substitution reactions are not favorable. That's one. And because these keywords are very important for the examiner, therefore we'll make sure that we underline them. Please do not take tension that we have to use a highlighter or a pencil. Whichever pen you're using, just from the same pen, underline the major keywords so that the examiner, while checking, can go through those words, because these are the words that the examiner is checking as looking for. Another important word is the partial double bond character. The moment the examiner sees these two important words, these two important points, they'll know that you know your answer. And then and there, you'll fetch 1 mark. Right? This is how I'll give the answer for first. Now, I'll move to the second question. It says, an ethyl ethanamine boils at this temperature, whereas butanamine boils at this temperature, although they both are isomers. So, whenever we are looking for the answer, we need to understand the structures. So, butanamine means 4 carbons and an NH2 group. And ethyl ethanamine means 2 carbons with an N, ethyl group and an H. Now, what is the difference that you can see here? Yeah. So one is primary amine and the other one is a secondary amine. Now, this is the part which you have done in NCERT, right? So you know that Secondary, primary amines have the highest boiling point, followed by secondary, followed by tertiary. And this is due to the presence of hydrogen bonds. So here, there is tendency to make 2 hydrogen bonds. Here, 1 hydrogen bond. In tertiary, no hydrogen bond. Okay? So, if I talk about this answer, you do not have to write much here. But you make sure that whenever you are writing this answer, draw the structures, even if the person has never asked you to do so. Okay? So you make sure that whenever you're writing the answer, you should write that, yes, butanamine. In the bracket, you can write the structure. But whenever you're writing the structure, please make sure that you are writing the complete structure. All the carbons, hydrogens properly expressed. So this is butanamine. Boils at higher temperature than N-ethyl ethanamine. Again, in the bracket, please draw its structure too. So it is CH3, CH2, NH, CH2, CH3. Due to presence of more hydrogen bonding, or due to its tendency to undergo more hydrogen bond. Right here, hydrogen bonding or more hydrogen bonding is the key. And what you can also do is you can make sure that this part is visible. Madam, you are highlighting this part, that you can highlight this part and say that there are 2 hydrogens for hydrogen bonding. Here there is 1 hydrogen available for hydrogen. Or while you're writing this, you can make sure that the structures you are writing at the bottom, and at the bottom you can write that there are 2 hydrogens available for hydrogen bond. And here you can mention 1 hydrogen. Right? Makes sense? So it's not that the lengthy answer, you have to just make sure that you are writing down all the important points over here. Then we'll move to another thing, that is acylation of aniline is carried out in the presence of pyridine. Acylation of aniline is carried out in the presence of pyridine. I'm sure you have seen this. Okay. Now, acylation reaction means, if you talk about aniline, aniline is C6H5. Now, why you are giving the answer to this part of the question? Because it is a reaction-based question, right? Whenever there is a reaction-based question, you make sure that you write the reaction. If the reaction is not happening, so you can just write that no reaction under normal conditions, like in the first case. So this reaction was not willing to take place under normal conditions, so you will write it. But you make sure that you are mentioning it. So the same way, if I talk about aniline, which is being acyl, so this is happening in the presence of acyl chloride. Okay. And pyridine's presence. So you will write both the cases. Then you will write the corresponding product. So you remember, I hope you remember that in the last class, in our last session also, we had a discussion that whenever any amine undergoes a reaction with corresponding acid or acid anhydride or acyl chloride, then it always yields the amide formation. then it always yields amide formation. So this is the formation of my amide. Right? This is the formation of amide. Along with this amide, one hydrogen from here and one Cl from here will combine together to form HCl. Now you'll write this reaction and then you will write during acylation reaction, HCl so produced reacts with pyridine, so that the reaction keeps on moving in forward direction. This is in accordance with, this is as per Le Chatelier's principle. All right, so this reaction is happening in the presence of pyridine specifically so that the HCl, which is so produced, HCl is an acid, pyridine is a base, they will react together, the reaction will proceed in the forward direction. Because in the Le Chatelier's principle, we know that if one of the product is consumed, then the reaction keeps on proceeding in the forward direction. Okay, and the important keyword is that HCl reacts with pyridine. Okay, now I'm not marking Le Chatelier's principle here. Technically, it is also a very important word, rather a keyword. Now, there's an important tip for you that the things which are not mentioned much in NCERT, if you know by your extra knowledge, it's good. You can even write it. Do not mark like as a fancy thing that it should be quite bulging out in the answer. Okay, so that is not exactly appropriate. So you should always be marking those keywords, more importantly, which are the part of NCERT. Okay, but you make sure that whenever there is a reaction-based question, to write the reaction is very, very important. Right? Writing the reaction is really important. So that is the answer for the third part. And now we'll move to the fourth part. They say that acetylation of aniline reduces its activation effect, which is true. Now, even for the fourth part, I would recommend you to write the reaction again. Even for the fourth part, even if you have done both third and fourth part, if you are doing, see, you have a choice to answer any four. Okay, but in case your choice involves both third and fourth part, even then you have to write this reaction again. Okay, make sure. So, reaction. Okay, when you'll write the reaction, then, okay, then in this part, when you're writing this one of the products, then mention that after that. So highlight this part, okay, again with the lone pair, and then write that since the lone pair present on nitrogen, make sure there are no shortcuts in CBSE answers. Okay, it's not that for nitrogen, I'll just write N. I have to write the entire thing. Since the lone pair present on nitrogen is involved in resonance, from two sides. From two sides. Therefore, its activity is decreased. Its activity is decreased. Okay. Then you have to show the resonance in this question. You have to actually show the resonance like this way, right? Its corresponding resonating structure. This is one. Okay. And then you have to draw it again. Though the question is just for 1 mark, but to make sure that you are not losing marks, we are doing this because we do not know exactly how the examiner wanted us to write the answer. So we'll not lose any, we'll not keep any loophole while presenting our answers. So it doesn't share the electrons with the phenyl group. It doesn't share the electrons with the phenyl group as in, so it is doing it equally from both the sides. Right, Dhyan? It doing it from both the sides. Right. So this is one of the paths, right? All right. So this is how we have to write the answer for this 3-marker question, the entire one, to fetch full marks, right? Next, I move to the next question, which is 37th. Again, this is having 3 parts for sure, each part 1 mark each. Accordingly, we'll write the answers. First question is, write the IUPAC name of the following complex. Please make sure that the examiner does not remember each and every question. Okay, there's no possibility. So they do not remember the exact sequence and everything. So it's good that when you're writing in your answer sheet, so if you're mentioning answer number 27 first, okay, you write this molecule and then write its IUPAC name. Whenever there is a question of that sort, you have to give the IUPAC name of any molecule, be it organic, inorganic. You write that compound for sure, so that it becomes easy for the examiners to cross-verify. Okay, that's a good habit if you'll do this. Now, so the name would be, we know that first we'll write the cationic part followed by anionic. So it is always, the first part has the first letter in capital, it's potassium. A very small space in between, and then I'll write the anionic part. So in the anionic part, we have to mention the total number of ligands and the names of the ligands in alphabetical order. So that's right, Dhyan. Right, Latika. Okay. Now, in this, so this is potassium tetrachloropalladate, right? Because whenever there's a central atom which is lying in the anionic part, we have to make sure that it ends up with 8, followed by its oxidation state in Roman numerals, which is 2. I hope you all know how to find out the oxidation state, right? So that is the only thing. And this is such a simple question. Here, you will get 1 mark. Direct question, easy question, 1 mark question. Then they say that using crystal field theory, write the electronic configuration. That's it. I just have to write the electronic configuration of D5 ion if delta naught is greater than pairing energy. Now, you know that in the CFT part, the d orbitals split into T2G and EG. Now, they have not mentioned that which type of complex they do want. They want octahedral or tetrahedral. So for that, they have mentioned delta naught. You remember that O is for octahedral. So that means they want it for octahedral splitting in which delta naught is greater than pairing. So in delta naught part or in octahedral splitting, T2G lies at the bottom and EG lies at top, right? So this is important for us to know that who's at the bottom, who's at the top, then only we'll start filling the electrons, right? Now, since they are saying that if delta naught is greater than P, if delta naught is greater than P, then pairing of electrons will occur. Hence, for D5, or otherwise you can just write hence the electronic configuration of D5. Hence, electronic configuration of D5 is, then you'll write T2G5, EG0, because pairing has taken place. Good, Latika, right? So this is the way that we have to work on. We'll just write the electronic configurations. Okay. And we are mentioning it to my examiner that, okay, why have I done the pairing? Because of this reason. And the way I have put it in a box, it's good if you'll put it in a box, because that will give it a proper point to the examiner. So this is my answer. This is the reason. It's a 1 marker question, so you do not have to explain much about it, or you do not have to draw the diagrams technically. Okay. It's not mandatory that you draw the diagrams. Okay. Even if you are drawing, not a problem. If someone is drawing the diagram and you're drawing it like this way, but you mentioned that you write everything, T2G, EG, 5 electrons, you're showing, then you're writing electronic configuration for D5 is T2G5, EG0. But still you make sure that this has to be written, even if you're drawing the diagram. Right? So whichever way you want to do, that is all right. Third question, what are homoleptic complexes? Again, this is the part which is coming from this coordination of compounds chapter from the basic terminologies part. Okay, so in the first 2-3 pages, you are given with these terminologies important. That's right, Latika. So homo means same, leptic as in ligands. So in this, you will be mentioning those coordination complexes, those coordination complexes or compounds containing same containing or composed of same ligands. Composed of same ligands are known as homoleptic complexes. Now, this answer is still incomplete. Important keywords is same ligands, right? But this answer will only be completed when you will give an example. Okay. And for your simplicity, you can just take the first example itself. There's no harm. There's no harm. You can take this example. You can take this example. Same ligands, right? So these are just the examples. And this is how we break through with our answer, right? I hope this all makes sense to you guys. So the important part about this way is to get a hold on about our answers, and the answers are not different. And make sure that whether you talk about MCQs, case study questions, short answers, long answers, they all are same. Okay, they all are same. They all are having the same way of writing. It's just the amount of portion that I have to write in the answer. That varies depending on my marks. That's it. Okay. Here, we have come to an organic question where they are saying, how are the following conversions carried out? Mostly, see, conversions, if you ask me, for sure it's a question of your boards. It's like almost 100% that a question on conversion will be there in your examination, be it in the form of a choice question, be it direct question. Okay, but it will be there. Another important point, what I have observed is that mostly they do not ask any questions which is outside NCERT. So please understand, NCERT is your major reference book. Whichever conversions are there, so there are many conversions which are given in hydrocarbons chapter, aldehydes and ketones chapter, amines chapter, okay, alcohols, phenols, alkyl halides, the haloalkanes and haloarenes chapter. You make sure that each and every conversion you have understood and you have revised at least 3 times. At least. Then only you'll be able to get a grip of it. Okay. Now, here, the first one is ethyl cyanide, and all these conversions, like by chance, this question is having all those conversions. This is one step conversions mostly. For example, they are saying ethyl cyanide. Okay. Oh, this is not one step though. Okay. So ethyl cyanide, if I'll say, and I want to convert it into ethanoic acid. So ethanoic acid is this. Whenever you have to do any conversion, make sure that you write the 2 things just for your comparison. Okay. So here, what do I see? That in my final product, there are 2 carbons, but in the starting reagent, there were 3 carbons, right? So what do I have to do in this case? To do this conversion, the first step which I can do, see, I have to reduce the number of carbons from 3 to 2. One of the major ways by which I know that I can reduce the carbon is removal of carbon in the form of carbon dioxide. That decreases the number of carbons by 1. That always decreases the number of carbons by 1. So whenever you have to reduce the number of carbons, like mostly, so there are 2-3 ways which we do. Either we convert it into the acid, okay, then convert it into the salt and treat it with soda lime. That will remove the carbon as carbon dioxide. That's one way. Another case, convert it into amide. If there's amide, Hoffman bromide, it also removes 1 carbon by removing it in the form of carbon dioxide. That's another reaction. So soda-amide reaction, Hoffman bromide reaction. Then suppose you talk about ozonolysis. So if there's a double bond, you're breaking it and converting it into 2 parts. So that way also you're decreasing the total number of carbons, right? This is another common way. So these are the 3 most common ways by which I reduce my carbon. Okay, by which. Now here, since I have to reduce it by just 1 number, so what I'll do is first acidic hydrolysis. So the moment I'll do hydrolysis of it in the presence of an acid, it gets converted into COH. It gets converted into COH. Then what will I do? I'll treat it with sodium to get it in the form of its sodium salt. Okay. Then I'll treat it with soda lime. So soda lime is NaOH in the presence of calcium oxide and heating. So when I'll do that, what will I get? So I get C2H6 and CO2 gases removed. Right? Now, oh, it's a very long process. I can see that. Okay. Then, next thing that I'm going to do is treating it with chlorine in the presence of light. So this will give me C2H5Cl. One of the hydrogen is replaced with this. Aqueous KOH or NaOH will give me C2H5OH, right? And then I can do its oxidation in the presence of KMNO4 and H+, and this is going to give me CH3COH. Oh, such a long one, right? This is one way. Another way of doing the same thing. So this is just one way. If you can, like, if you know, you do not have to remember. You try to understand it. The more you understand it, the better it will be for you to get a hold on conversion. Or what is the other method? As I said, Hoffman bromide is also one of the ways, right? So I can do partial hydrolysis. So partial hydrolysis of cyanide will give me an amide, right? Then I treat it with bromine in the presence of NaOH, which is Hoffman bromide. I'm getting C2H5NH2, which is primary amine. This primary amine, if I'll treat it with HNO2, that is diazoniums, NaNO2 in the presence of HCl or HNO2, then this is going to give me this compound. So if you know primary aliphatic amine, when it is treated with the NaNO2 in the presence of HCl 0 to 5 degrees Celsius, it always yields alcohol. And then if I'll treat this alcohol with KMNO4 in the presence of an acid, which is a strong oxidizing agent, then I'm going to get CH2COH back again. Right, Latika? You wanted me to do it with this method also, right? So this one. Whichever way you would like, it will work. Right? So this was for first. Second is butane 1-ol to butanoic acid. But this one is easy if I talk about this, because just now you have seen butane 1-ol means C, 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 and OH, right? This is butanol. Oh, of course, there are CH3s involved. I have not written though. Converting it to butanoic acid, that means the last carbon is COH. So basically, this CH2OH is getting converted into COH back. It's one step. Acidic KMNO4. Work done. Because that is a strong oxidizing agent that will convert my alcohols to acid with same number of carbon. So even if one part of it was so long, you can see that second part is so short that it will balance out the timing. Okay, so you cannot say that all the questions are equally of the same length and will involve the same number of amount of time. Third is benzoic acid to meta-bromo-benzoic acid. Okay, again, this involves not more than one step. So this is my benzoic acid. And this is meta-bromo. Now I know that COH is a meta-directing group. Okay, since COH is a meta-directing group, what will I do? I will simply add bromine in the presence of acetic acid or CCl4 to get this. Normally, for this reaction, I'm not going to use Lewis acid. Please do not use anhydrous AlCl3 and AlBr3, okay, or FeBr3. Do not use that because benzoic acid is not susceptible towards the reaction with Lewis acids. Reason being because they're electron rich and Lewis acids are electron deficient species. So they can have a side reaction, which will hinder my product formation. Right? So we have to be so these are a few parts where we have to be more careful about during our conversions. Same way, if I talk about aniline is also not very good towards Friedel-Crafts reaction or towards Lewis acids. Again, because of the fact that they will form acid-base reactions. Okay, so it's not a rich idea to go with that. I hope this is clear. Right. And then I move to our next question, which is 29th. Now, in this question, I really wanted to discuss this question. Reason being, you can see that in this question, a lot of extra information is given. The boiling point is given as this, all right. Kf value is also given. Kb value is also given, right? This is my Kb. This is my Kf. Now, this part, so these are the informations about the electrolyte. So this is my non-electrolyte. Right, this is a non-electrolyte in which I'm adding my solute. This is my solvent's amount, right? And I asked you, what is the freezing point of the solution? Now I know from solutions chapter that if I want to calculate the freezing point, so delta TF is equal to Kf into M into I, where I is the want-off factor. Now, since urea is a non-electrolyte, this want-off factor value is 1. Right? Kf is already given in the question. And for molality, we can find it out. So how do you find molality? It is the moles of solute per kg of solvent. So moles of solute is like mass of solute by molecular mass into 1000 by mass of solvent in grams. Right. So over here, I just have to substitute the values. I know the value of Kf. I know the mass of solute, which is 6 grams. I know the molar mass, like I can calculate basically. I do not know, but I can easily calculate. There are 2 nitrogens, so 14 into 2. There are total 4 hydrogens, so 4 into 1. Okay. 12 into 1 is for carbon, 16 into 1. So I just have to add this mass to get the molecular mass. I think it will come around 60 into 1000 by mass of the solvent, which is given as 200 grams. Right. All right. So by this way, I can just get the delta TF value. And then to get the freezing point, it will be 0 degrees minus the delta TF. And I'll get the freezing point. Now, why did I say that there was too much information? Because I have nowhere used this information at all. I haven't. This is just additional information for me. And these are the things which confuses us, because when we are not using an information which is provided to us already, we always are in a form of dilemma that, okay, we are always in the form of dilemma that, like, am I missing something? Was there more to it, which maybe I have missed out? And that creates a problem, isn't it? That really creates a problem because we spend too much time wasting. Okay, I hope this was clear. I hope you understand this was a very direct question. Just formula application. Just formula applications. You make sure that whenever we are writing the formula, inform each thing that, okay, what does delta TF represent? What is KF representing? What is M representing? What is I representing? Okay, and how to put the values properly, solve each thing, give the answer, you will 100% get 3 marks. Okay. Then I'll come to the next thing, that is the 30th question. In the 30th question, if again, I'll go with the first part. Okay. So then they are asking to identify the chiral molecule in the following pair. Just have to identify the chiral carbon or the chiral molecule. So basically, what is a chiral molecule? Okay, so for the chiral molecule, basically, what we need to understand here is, I'm looking for a chiral carbon, technically. I'm looking for a chiral carbon. So they both are same, actually. I don't think there is any difference in these two structures. Right. So now, if I look at this, now what is a chiral carbon? A chiral carbon is that carbon in which all 4 different substituents are attached to the carbon. So to one carbon, if all four, see, one carbon is capable of having 4 bonds maximum. So it is that sp3 hybridized carbon at which all 4 different substituents are present, right? Now, if I look at this carbon, there is CH3 and there's another CH3. Then and there, this is not my chiral carbon. This can't be. Because I want 4 different things. I'll move to this carbon. So there is 1 hydrogen. Okay, good thing. 1 part is OH. Good enough. 1 part is CH3. Again, all 3 are different. 1 is hydrogen, 1 is CH3, 1 is OH. And then 4th part is this entire molecule, isopropyl. So all 4 things which are present on it are different. As a result, this carbon becomes carbon. This carbon becomes chiral. Now, if one of the carbon is chiral, the entire molecule is here, right? Because we are talking about only one chiral carbon. So then entire molecule is chiral. Though it is not mandatory depending on, like you might have done in enantiomers and mesomers as well. It's not mandatory that just because of the presence of a chiral carbon, there will be a chiral molecule, but here it will. Okay. The second one, again, this carbon is chiral. So if there is a chiral carbon, I just mark it with an asterisk sign. This is isopropyl group. This is OH, all 4 different substituents. So carbon. Okay. Now, so this is the way so when you are writing this answer, you have to first of all explain it to the examiner. What do you mean by a chiral carbon? And then show it. Draw the structures individually and show it. Okay. And then what can I say? I can say that this pair forms, this is a enantiomeric pair. This is an enantiomeric pair. Okay. So you can just write down that way, or you can just explain it using R&S nomenclature. Though since it is just one marker, that is not required. Okay. Then they say in the second part, write the structure of the product when chlorobenzene is treated with methyl chloride in the presence of sodium. So when chlorobenzene is treated with methyl chloride in the presence of sodium and dry ether, I know this reaction is Wurtz-Fittig reaction. Okay, so I would suggest that when you are writing, they are just asking you to write the structure of the product. So you just have to write the reaction. You do not have to do any explanation. You just have to write the reaction. Okay, and this you will be mentioning as the major product. And in this reaction, it is better if you will write or mention the name, it is Wurtz-Fittig reaction. This reaction is Wurtz-Fittig. See, if you'll not write it, no issues. Okay, but do not write the wrong name. If you're not clear or if you do not remember the right name reaction, it's all right. But it is always good that if they have given any name reaction, you write the name of the reaction because that's famous. Okay. Otherwise, just if you'll write this much, will work. Third and the last part, which we are going to do for today's discussion, is write the structure of the alkene formed by the dehydrohalogenation of 1-bromo, 1-methyl cyclohexane. Okay, with alcoholic KOH. Now, the most important part is just in this part, you have to draw the structure. So this is cyclohexane, 1 bromo and 1 methyl. Then when I treat it with alcoholic KOH, okay, so basically there has to be a loss of HBr. Okay. So the loss of HBr, the hydrogen should go from the side carbon. So that is beta carbon. So it's a beta elimination. So you can write it beta elimination because this is something which is mentioned in your NCERT. So it's good that you write that it's a beta elimination. Then since it is a loss of HBr, you can mention it this way and draw the corresponding alkene. Okay. Write the structure of the alkene form. So you should write this as the major product plus HBr. That's it. They do not want any explanations. They do not want how you have received it. They do not even want what is the minor product. So if they ask you the question, write the difference, write the structure of different products obtained by the dehydrohalogenation. In that case, you can also mention, okay, if they ask you products, then only you can mention the minor product also, which is this. This is the minor one. But since they have not asked you, you just write the major product and the HBr, work done. Do not explain much. Okay? And you will fetch your 1 mark. I hope you've understood how to work well and how to get the right choices for your 3-marker question. Never hesitate for writing lesser part or writing too much, depending on where it is the requirement. But make sure that you underline all the important things. Wherever there is a formula, put it in a box. Whichever part is important, put it in a box, particularly when your writing is big and something important might be missed out. All right. So that's my important tip for today. And in our very next session, we will be working on the long answers and how to work on those. We're taking a few examples from here and there and working on that. Right? Also, we'll be working on the next chapter, which will be kinetics. So if you really want to learn the kinetics chapter in like just 1 hour, feel free to come and enjoy the session. All right. Till then, take care. Bye. This is me, Bhavya Agrawal, signing off for today.